Good afternoon, students. Today we are going to start with the chapter lesson 15 Some Natural Phenomena. Phenomena means fact or event. In this chapter we are going to discuss about charging by rubbing, transfer of charge, the story of lightning and thunder, earthquakes. Now students, in class 7th we have learned about storms and cyclones. We know that storms and cyclones can cause a lot of damage to human life and property. But we have also learned that we can protect ourselves from this destructive phenomena to some extent. In this chapter, we shall discuss two other destructive natural phenomena, that is lightning and earthquake. We shall also discuss what steps we can take to minimize destruction caused by this phenomena. Now students, we can see electric sparks on the electric pole when wires become loose. We can see electric sparks when a plug is loose in its socket. So sometimes we notice a flash of light all over the sky during rain and thunderstorms. Now this natural phenomena is called lightning. So lightning is also an electric spark, but on huge scale. So lightning occurs because of massive electric charge. Massive means in large quantity. When electric charge is flowing from one part of the cloud to another part of the cloud, or from a cloud to the ground. To understand how this happens, let us first learn about electric charge. Now students, when I am explaining this, observe the first image. Okay, plastic comb and small pieces of paper. Now to show that charge body attracts small pieces of paper towards itself, what we are going to do? We have to bring the plastic comb near the small pieces of paper. You will see that comb does not attract. But when we are going to use the same plastic comb, when we are going to rub this plastic comb on our dry hair, so what will happen? It gets charged. And now bring the plastic comb near the paper pieces. Now this time you will see that it attracts small pieces of paper. So from this what we have concluded? That plastic comb gets electrically charged on rubbing. Okay, so charged body attracts small pieces of paper towards itself. Now see the second image. To show that electric charge body is attracted by an uncharged body, what we are going to use? We are going to use a balloon and woolen material. In this activity, what we are going to do? You have to inflate a balloon by blowing air in it. Now rub this balloon with a woolen material and place it against a wall. Now after a few minutes what you will see? That balloon sticks to the wall. So from this what we have concluded? That balloon gets electrically charged on rubbing against a woolen material. So rubbing a comb against a dry hair or rubbing a woolen material produces a kind of force that can attract also and can repel also. So that type of force we are saying electrostatic force, and body having an electric charge on it. So here what we can say? Here we can say comb and balloon are called charged body. Why? Because they are having electric charge on it. And the process of giving an electric charge to an object. And how we are giving an electric charge to an object? By rubbing it with another object. So that process we are saying charging the object. Charging an object by rubbing it with another object is called charging by friction. Now students, let us discuss about two kinds of electric charge, that is positive charge and negative charge. Now through various experiments we have learned that electric charge on a glass rod when it is rubbed with a silk cloth is considered positive, and the electric charge on the ebonite rod when rubbed with fur or wool is considered negative. So who has discovered these two kinds of electric charge? That is Benjamin Franklin. Now to understand this, let us go through this activity. So this activity shows that like charges repel each other. So what we are going to use? See the first image. We have used two glass rods, okay, and in second image you will see we are using two ebonite rods and a piece of silk cloth, a piece of fur, wooden stand and silk thread. What we are going to do now, when I am explaining this, see the first image. We are going to rub a glass rod with a piece of silk and we are going to suspend it with a silk thread to a stand as shown in figure. You can see in figure. Now bring the another glass rod, rub it with the silk cloth and we are going to bring it near the suspended rod. Now when we are going to bring it near the suspended rod, what you are going to observe? You will observe that suspended glass rod moves away from the other glass rod. Why? Because both the glass rods are having a positive charge. So as they are having a like charges, so they will repel from each other. Now see the second image. In this, what rod we are going to use? Ebonite rod. Now rub an ebonite rod with fur and hang it with a silk thread to a strand. You can see in image how it has been done. Now rub the another ebonite rod with fur and bring it nearer to the suspended charged ebonite rod. Now this time what you are going to observe? You will observe that suspended ebonite rod moves away from the other ebonite rod. Why? Again, both the ebonite rods are having like charges, that is negative charge. So as they are having a like charges, so they will repel from each other. So from this activity what we have learned? That like charges repel each other. Now in this activity what we are going to learn? That unlike charges attract each other. Now here what we are going to use a glass rod, piece of silk cloth, a wooden stand, silk thread, ebonite rod and a piece of fur. Now what we are going to do here? We are going to suspend a glass rod rubbed with the silk cloth to a stand using a silk thread. Now bring an ebonite rod rubbed with a fur near the suspended glass rod. Now you will see that glass rod will have positive charge and ebonite rod will have negative charge. So after a few minutes when you are going to observe this, what you will see? That suspended glass rod gets attracted towards the ebonite rod. So from this what we have concluded? That unlike charges attract each other. Now students, let us discuss about transfer of charge. Now to understand this concept of transfer of charge, first we should know about gold leaf electroscope. So gold leaf electroscope consists of brass rod, you can see in image, which passes through a rubber stopper in a glass jar. this rubber stopper we can also say insulator plug. At the top end of the brass rod carries a brass disc, and the lower end carries the two thin gold leaves such that they hang parallel to each other. You can see in image that how it is been hanged. Now glass jar protects the gold leaves from the outside air current. From the outside atmosphere it protects, this glass jar protects this leaves. Now at the lower part of the glass jar, what you can see? You will see that its interior is surrounded by a metal foil. Now when this electroscope is used, the metal foil is earthed, okay, that we are going to learn ahead. This increases the sensitivity of the electroscope. So some electroscope have leaves of silver, copper, aluminium or brass instead of gold. Now students, in this activity we are going to learn transfer of charge from charged body to an uncharged body. Okay, so what are the things required? We need a glass rod, silk cloth and electroscope. Okay, now what we are going to do, we are going to rub the glass rod with a silk cloth. We are making it charged. We are charging the glass rod. Okay, now glass rod will have positive charge. Now we are going to bring this glass rod in contact with the brass disc of an electroscope. So what you will see, that on touching the charged rod with the brass disc, the charge is received from the charged body to the brass disc will flow along the brass rod to the gold leaves. And we know that metals are good conductor of electricity. So the gold leaves carrying the similar charges will repel from each other. Repel means it will move away from each other. So therefore the leaves will become wide open, it will get diverged. Okay, so from this what we have concluded, that electric charge can be transferred from a charged object to another through a metal conductor. Now students, let us learn about earthing. Okay, again we are going to take electroscope. We are going to charge the electroscope by touching its brass disc by the glass rod. Rub with the silk cloth. Now we will see that leaves of the electroscope diverge, it will open up. Okay, when I am explaining this, observe the figure A. Okay, you will see that leaves have been opened up. Now see the second figure. In that what you will see, when we are touching the end of the brass disc gently with the hands, what you are going to observe, you will observe the change in the leaves of the electroscope. The leaves of the electroscope comes back to its original state. Now repeat this, charging of an electroscope and touching the brass disc with the hand. So every time you will find that the leaves of the electroscope collapse as soon as we touch the brass disc of the electroscope. Why? Why it is happening? Because the reason is that the gold leaves lose that charge to the earth through our body. So we can say that electroscope leaves are discharged. Okay, so the process of transferring of charge from charged body to the earth is called earthing. Now students, let us learn about the story of lightning. Now this event has taken place in the year 1752. Okay, in USA. A 46-year-old Benjamin Franklin, he is an American scientist, has decided to fly a kite with the help of his son William. So for that what he has done, he has attached his kite to a silk string and tying an iron key at the other end. Next what he has done, he has tied a thin metal wire from the key and inserted the metal wire into the Leyden jar. Now Leyden jar is a container for storing an electric charge. You can see in that image. Okay. So finally when sky got darkened, Okay, as the sky was darkened and thunderstorm approached, they attached the silk ribbon to the key, and holding on to the kite by the silk ribbon, Benjamin flew the kite. And when the kite was into the air, he went into the barn. Barn means a large farm building used for storing grains. He went into the barn so that he would not get wet. So when storm cloud passed over the Franklin's kite, what has happened? The negative charges in the cloud leaked onto the kite, then to its string, kite string, his key, and then to the Leyden jar attached to the key by a thin metal wire. Franklin was unaffected by the electric charge. Why? Because he was holding a dry silk string which insulated him from the charges on the key. Now when Franklin touched the key with the finger, so he has received the shock because the negative charges in the key were so strongly attracted by the positive charges in his body that the spark jumped from the key to his hand. So he got the shock. So Franklin's experiment successfully showed that lightning was actually a static electricity. Okay, static electricity, already we have learned electrostatic force. Okay, so Franklin realized that this form of electricity would be charged over a conductor and passed on into the ground. So keeping this in mind, he has invented the lightning rod and lightning conductor, providing the lightning an alternative path to the earth. Now students, in this slide we are going to discuss that how lightning and thunder occurs. So as you all know that cloud contains a tiny crystals of ice and droplets of water. Now this tiny crystals of ice and droplets of water move against each other. So as it moves against each other, it produces a huge amount of charge in the cloud. So ordinarily nothing happens due to this charge buildup because air does not conduct the charge from the clouds. But when the accumulation means collection of the charge is great enough, and when the wind brings this cloud close together, the charge jumps from one cloud to another through the air. Now this sudden rush of electric charge heats up the air to about 30,000 degrees Celsius, producing a bright glow of lightning. Now this rapid flow of electric charge through the air between two oppositely charged clouds, seen as an intense spark of electricity in the sky, is called lightning. Now during this process, huge amount of energy is released in form of light and heat. Due to the heat produced at the time of lightning, the air gets heated up and expands suddenly. So this rapid expansion of air sends a disturbance in form of vibration through the air, producing a loud sound. So this loud sound produced during a lightning is called thunder. Now this is the lightning we see and thunder we hear during a thunderstorm. So an electric discharge or lightning can occur not only between two clouds but also between a charged cloud and the earth. A cloud has a negative charge concentrated at the base and positive charge concentrated at the upper side of the cloud. Now when charged cloud passes over a tall building or a tree, the negative charge at the base of the cloud pulls the positive charge from the tall building or trees in upward direction. So as soon as the negative charge and positive charge connects, a continuous path is formed from the cloud to the tall building or a tree on the ground. So this will give a rise to an electric discharge in the form of lightning strike. So when electric charge flows between charged clouds and a tall building, we say that lightning has struck in the form of a lightning strike. Now students, let us discuss about the harmful effects of lightning. So lightning strike generates a huge amount of electric charge. So lightning bolt has a temperature of about 30,000 degrees Celsius. So it can cause fire and shatter building. Shatter means break building, resulting in lot of destruction and damage to the property. Second, it can burn trees and also cause forest fire. Third, it injures or sometimes even kills animals and people instantly. Now students, let us discuss about lightning conductor. So when I am explaining this, observe this image properly. So a lightning conductor is fixed on the top of tall building to protect the building from damage due to the lightning. So it consists of long lightning rod of iron or copper with a number of sharp, long, pointed rods at the top end. Now this rod runs from top to the bottom along the outer wall of the tall building to be protected, and the lower end of the rod is connected to the metallic plate. Now this metallic plate usually made up of copper, which is buried deep into the earth to provide a good earth connection. Now when lightning strikes the building, the lightning conductor provides an easy path for the charge to pass through to the earth, thus protecting the building. Now in absence of such lightning conductor, the current flow from the lightning will pass through the building, thereby causing a lot of damage to the life and the property. Now students, let us discuss about safety measures to be taken during lightning. So if you are outside your house, so what safety measures you can take? First, when you hear thunder after the lightning, rush to a safer place. So an appropriate shelter could be a building or a car with closed windows. Second, do not lie flat on the ground. Third, do not take shelter under a tree because tree provide a good conducting path for lightning. Next, if you are in group of people, stay about 15 feet away from each other. Next, stay away from all type of water bodies. So, as you all know that water is an excellent conductor of electricity. Next, open vehicles like scooters and motorbikes do not protect us when lightning strikes. Next, come down from elevated place. Elevator means raised to an higher level, means at the top of mountains or hill, mountain or rooftop of a building. If you are in forest, take shelter under shorter trees. So, as this, shorter trees are less likely to be a lightning strike site. Next, get as small as you can by crouching. Crouching means by bending on your knees on the ground. Place your hands on your knees with your head between the hands. So this position will make you a smallest target to be struck. Now indoor safety measures. So if you are inside your house, so what safety measures you can take? First, avoid using electrical appliances such as television, air conditioner, computers, etc. As you all know that electrical lines are excellent conductor of electricity. So it is advisable to unplug these electrical appliances. Second, do not take bath or shower during storms, as water is an excellent conductor of electricity. Next, lightning can strike telephone cords, electrical wires and metal pipes, as these all things are good conductor of electricity. So during thunderstorm, contact with this object should be avoided. It is safer to use mobile phones and cordless phones, and stay away from plumbing lines, because such pipes are made up of metal, which again it is a good conducting path for the lightning bolt.